Picture a cave in the hills of Asturias, in the north of what is now Spain. The air is cold and still, the stone black, and the year is roughly 49,000 years before the present. In that darkness there is a body, not a monster, not a myth, but a person, heavy-browed and broad-shouldered, sitting with one hand pressed against the side of a swollen jaw. Inside that jaw, an abscess is eating slowly into the bone. The pain is constant, the kind that hollows out a face and steals sleep, and this individual has been living with it for a long time. We know this person existed because of what stayed behind in the mouth. On the surface of the teeth, layer upon layer, sits a crust of hardened dental plaque. Archaeologists call it dental calculus, and it is one of the strangest time capsules the human body produces. It traps whatever passes across the teeth, tiny grains of starch, fibers, spores, and stray chemicals, and then fossilizes in place, sealing those fragments of a single life for tens of thousands of years. Karen Hardy has called it one of the most underused archives in all of archaeology, a record written not on stone or bone, but inside the mouth of the person who lived it. In the year 2012, the archaeologist Karen Hardy and her colleagues took that calculus apart, molecule by molecule. Locked inside it, they found the chemical traces of two plants. One was yarrow, the other was chamomile. Both are intensely bitter, both are famous in the herbal record as medicine, and crucially, both are close to worthless as food, offering almost no calories to a body fighting cold, hunger, and infection in the middle of an ice age. So here's the puzzle that opens everything. Why would a starving hominin, one that was not even a member of our own species, deliberately choose something bitter, useless as a meal, and flagged by its own taste buds as a warning? The obvious answer is that this creature was using the plant to change how its body felt, which forces the real question of this whole investigation. When did that start? When did the beings on the road to us begin reaching for chemistry to alter themselves? The honest answer runs backward past these Neanderthals, past our own species entirely, all the way down to a single mutation that is about 10 million years old. Ask most people when humans started doing drugs, and the answer comes back in the low thousands of years. They picture Sumerian tablets describing the poppy, and Egyptian tombs stocked with beer, robed shamans somewhere swallowing mushrooms. It feels like a story that belongs to the first cities, to writing, to civilization. That answer is not wrong so much as it is shallow, like dating the ocean from the moment you first learned to swim in it. The deeper story has 3 layers, and it helps to hold all 3 in mind at once, even though the people living it never separated them. The first layer is chemistry, sitting inside the plants themselves, waiting. The second layer is the brain, wired with receptors that these plant chemicals happen to fit. The third layer is behavior, the actual reaching out and consuming, which turns out to be far older and far more widely shared than anything uniquely human. Follow those 3 layers down, and the meaning of the question changes under your feet. Drug use stops looking like a modern failing, a symptom of bored, comfortable, oversupplied lives, and starts looking like something inherited, written into the body long before anyone thought to write anything at all. To see why, we have to start not with people, and not even with animals, but with why these drugs exist in the world in the first place. Here's the first thing that upends the usual story. Plants did not evolve their psychoactive chemicals for us. They evolved them as weapons. Botanists call these compounds secondary metabolites, meaning they are not part of the basic machinery of staying alive and growing. They are extras, and almost all of them are defensive, brewed up to poison, paralyze, or repel the insects and animals that would otherwise eat the plant alive. Consider the everyday examples because they are startling once you see them clearly. Nicotine, the drug in tobacco, is a natural insecticide. The tobacco plant floods its leaves with it to kill the caterpillars and beetles that chew on them. Caffeine does the same job for the coffee and tea plants, poisoning insect larvae and even leaching into the surrounding soil to stop rival seedlings from growing. Morphine, the active compound in the opium poppy, is a bitter deterrent in the plant's milky latex. Every one of these is, from the plant's point of view, a chemical act of war. So why do these weapons make a human feel pleasure rather than pain? This is the reveal that ties the whole subject together. These molecules work on us because they are near-perfect forgeries of chemicals our own bodies already use. Morphine slots into receptors that evolved to catch the body's own painkillers, the endorphins. Nicotine fits receptors named after it, the nicotinic receptors, which normally listen for a signaling chemical called acetylcholine. The active compound in cannabis fits a receptor called CB1 that is part of a whole internal system regulating appetite, mood, and pain. The plant did not design a key for our lock. It happened to grow a molecule shaped like a key we were already carrying. The reason a forgery is even possible is that plants and animals are distant relatives. Go back far enough, well over 1 billion years, and we share a single-celled ancestor. That deep kinship means we run on overlapping chemistry, using similar molecules to send similar signals, which is exactly why a chemical a plant invented to jam an insect's nervous system can also slip into ours. The list of these forgeries is long, and it is not a coincidence. Cocaine, in the coca leaf, is a bitter alkaloid that poisons the insects feeding on the plant. Mescaline, in cacti like peyote and San Pedro, and the active compound in cannabis, are both biologically active defense chemicals that happen to be bitter, the taste of alarm. That bitterness is not incidental. Vertebrates evolved a dedicated family of bitter taste receptors precisely to detect these plant toxins and spit them out. In other words, our own bodies come pre-installed with an alarm system tuned to exactly these chemicals. And the entire history of human drug use is the history of learning to override that alarm on purpose. The great ethnobotanist Richard Evans Schultes spent a career cataloging the hundreds of psychoactive plants that peoples around the world independently found and used, which tells you how often this same discovery has been made. The convergence, so many unrelated plants arriving at neuroactive chemistry, reflects an ancient arms race between plants and the nervous systems of the insects eating them. Nervous systems built on the same basic plan as ours. Two researchers, Roger Sullivan and Edward Hagen, called this the paradox of drug reward. Intoxicants hijack the very circuits that evolved to reward useful behavior, like eating and mating, and they do it by mimicking the body's own messengers. There's even a competing idea, argued by Hagen, that our ancestors were positively adapted to seek out small doses of certain plant toxins because trace exposure carried benefits, such as clearing internal parasites. The debate is unsettled, but the underlying fact is not. The locks were installed in our nervous system tens of millions of years before any user came along to pick them, and whether a given plant chemical acts as medicine, as a high, or as a lethal poison comes down entirely to the dose. The same molecule can heal, intoxicate, or kill. All of which raises an obvious next question. What is the oldest such molecule our lineage ever met? The answer is almost certainly alcohol, and it was not invented by anyone. It brews itself. Wild yeast lands on ripe and overripe fruit, feeds on the sugars, and produces ethanol as a waste product. Any forest full of fruiting trees is, in a quiet and constant way, a distillery that never closes. Long before a single human existed, the raw drug was simply lying on the ground. The biologist Robert Dudley built an entire hypothesis around this, which he named the drunken monkey. First proposed around the year 2000 and expanded in his later book, the idea is disarmingly simple. The smell of ethanol is the smell of ripe, sugar-rich fruit at its peak of nutritional value. An animal drawn toward that scent would be led straight to the best food. So an attraction to low doses of alcohol, Dudley argued, was not a vice at all. It was a foraging advantage, a nose for calories. For years this was an elegant story without a hard date attached. Then, in the year 2015, the biologist Matthew Kerrigan and his colleagues supplied one. They studied an enzyme called ADH4, one of the proteins that breaks alcohol down in the body across 28 different primate species. By reconstructing the enzyme's evolutionary history, they were essentially reading a molecular clock. And they found a single decisive change. One tiny substitution in the protein, swapping one building block for another, made the enzyme about 40 times better at metabolizing ethanol. That upgrade did not happen recently. It traces back to roughly 10 million years ago, to the common ancestor we share with chimpanzees and gorillas. The timing is the beautiful part. It lines up with the moment that ancestor was shifting towards spending more time on the ground. And fruit on the ground is fruit that has fallen, bruised, and begun to ferment. meaning it carries far more alcohol than fruit still hanging in the branches. The enzyme upgrade let those apes eat the fermenting windfall without being poisoned or falling down drunk in a world full of predators. The living evidence backs this up. In the forests of Bossou in Guinea, wild chimpanzees have been filmed drinking naturally fermented palm sap, dipping crushed leaf sponges into it and lapping it up, sap that can reach several % alcohol. A small creature called the pen-tailed tree shrew, studied in Malaysia in the year 2008, spends its nights drinking fermented palm nectar strong enough to floor a person, and shows no sign of drunkenness at all. In controlled tests, other primates such as ayeres and slow lorsides actively prefer the nectar with the higher alcohol content, choosing the stronger drink when offered a choice. And in us, the descendants, a striking share of the liver's chemical machinery is still devoted to breaking down alcohol, a quiet sign of how long and how deeply this molecule has mattered to our lineage. Now sit with what this means. The taste for alcohol is not a human cultural habit picked up in the first villages. It is an inherited trait roughly 10 million years old, older than walking upright, older than stone tools, older than the genus we belong to. And here is the sting in the tail. The trick of distillation, of concentrating alcohol far beyond the 15% or so that fermentation can reach, is only 1,000 or 2,000 years old. Our bodies were tuned over 10 million years for weak, occasional hard-won doses. We now live surrounded by strong, cheap, endless ones. That gap between an ancient appetite and a modern supply is a large part of what we now call addiction. If the taste is that deeply inherited, the next question is whether the behavior is inherited too. Do other animals actually go looking for this? They do, and once you start looking, the examples are everywhere. There is a whole field devoted to it, given the name zoopharmacognosy by the researchers Eloy Rodriguez and Richard Wrangham. The word describes animals medicating themselves with plants, minerals, and other materials, and the best documented cases come from our close relatives. The primatologist Michael Huffman spent years watching wild chimpanzees do exactly this. He observed sick chimps swallowing the rough, bristly leaves of a plant called Aspilia whole without chewing, so that the leaves passed through the gut like scouring pads and physically dragged out intestinal worms. He watched ill chimps seek out and chew the intensely bitter pith of another plant, Vernonia, which contains genuine anti-parasitic compounds, and then recover over the following days. This is not random feeding. It is targeted, bitter, low nutrition consumption, timed to sickness. Move beyond medicine into pure intoxication, and the stories get wilder. Bighorn sheep in the Canadian Rockies have been seen climbing onto dangerous ledges to reach a particular hallucinogenic lichen, then grinding their teeth down to stubs, scraping it off the rock, coming back again and again. Reindeer in Siberia seek out the red and white fly agaric mushroom and stumble about strangely afterward, a behavior the region's herders noticed long ago. Jaguars in the Amazon chew the bark and roots of the very same vine, Banisteriopsis caupi, that people brew into the hallucinogenic drink ayahuasca, and afterward turn dreamy and subdued. The behavior is not limited to eating. Some lemurs in Madagascar deliberately bite toxic millipedes, which release defensive chemicals and then rub the resulting paste through their fur, apparently as an insect repellent and possibly for a mild narcotic effect on themselves. Domestic cats and their wild relatives, right up to the big cats, all respond to the chemical in catnip with the same rolling, blissful intoxication because they share the receptor that answers to it. Michael Huffman even worked out a set of criteria to tell true self-medication apart from ordinary feeding, looking for bitter, low-nutrition plants eaten in small amounts and timed to illness, and he found that these behaviors can be socially learned, passed from one animal to another within a group, exactly the way human knowledge of plants spreads. A word of caution is needed here, because this subject attracts tall tales. The famous image of elephants getting drunk on fermented marula fruit was tested by the scientist Steve Morris in the year 2006, and the numbers do not work. An elephant simply cannot eat enough fermenting fruit fast enough to get drunk. The claim about dolphins deliberately passing around a toxic pufferfish to get high remains contested and unproven. But strip away the exaggerations and a rigorous core remains, especially in the primate self-medication research, which is solid and repeatedly documented. Birds really do gorge on fermented berries and fall out of the sky. wallabies really did wander into Tasmania's legal opium poppy fields and behave erratically. What matters for our question is the pattern underneath. Seeking out plants to heal the body and seeking out plants to alter the mind are not human inventions. They are widespread animal behaviors, sometimes even learned from one another, and pass through a group the way human knowledge spreads. If the drive itself predates humanity, then our own drug use is less a thing we invented and more a thing we inherited and elaborated, which brings us to the nearest branch on our own family tree and to the plants found sealed in their teeth. Return now to that aching Neanderthal jaw in the cave at El Sidron. Karen Hardy's discovery of yarrow and chamomile in the dental calculus was striking on its own, but it did not stay alone for long. In the year 2017, a team led by Laura Weyrich sequenced ancient DNA from the same kind of Neanderthal plaque and found something even more pointed. One individual, the one suffering from a dental abscess and a nasty stomach bug, had been consuming poplar, a tree whose bark contains salicylic acid, the natural chemical ancestor of aspirin. The same person also carried traces of a penicillium mold, the family of fungi from which we later drew the first antibiotic. Read one way, this is astonishing. A Neanderthal in pain, chewing a natural painkiller, and swallowing a natural antibiotic tens of thousands of years before either was understood. It looks like self-medication so precise it borders on pharmacy. But good science demands the other reading too. Some researchers argue these bitter compounds could have entered the body incidentally, for instance from the stomach contents of plant-eating animals the Neanderthals hunted and ate. The line between deliberate medicine and accidental swallowing is genuinely hard to draw. The problem gets sharper at another site entirely. Shanidar Cave in the mountains of Iraqi Kurdistan was excavated decades ago by Ralph Solecki, and one burial there became world famous. Around the body known as Shanidar 4, the pollen analyst Arlette Leroy Gourhan found dense clumps of pollen from flowering plants, including yarrow, cornflower, and ephedra. It was christened the flower burial, and it seemed to show Neanderthals laying their dead to rest on beds of blossom. An ephedra note is not just decorative, it is a genuine stimulant, the natural source of the drug ephedrine. Here the ground opens under your feet. The evidence reads like the first prescription in human history until you meet the small animal that may have actually written it. In the year 1999, the researcher Jeffrey Summer pointed out that a local burrowing rodent, the Persian jurd, hoards flowering plants in its underground nests. A colony of these creatures tunneling around a grave could have delivered every scrap of that pollen with no human hand involved. A restudy of Shanidar published in the year 2023 found ancient pollen once again, but also clear signs of burrowing animals and bees, leaving the whole ritual reading unresolved to this day. None of this means Neanderthals were incapable. Far from it. They controlled fire, they manufactured birch bark tar through a genuinely complex heating process, and they buried at least some of their dead. A species that clever was surely capable of knowing its plants. And if even part of the El Sidron evidence holds, then deliberately using plants to change the state of the body is at least 50,000 years old, and it belongs not just to us, but to a cousin species as well, hinting at an inheritance from an ancestor we both share. But to escape this fog of ambiguity, we need a drug that leaves a mark not on a buried flower, but on the human skeleton itself. That drug is Betel, and it is a gift to archaeologists because it stains the body in a way that lasts. A betel quid is a small package of ingredients: the seed of the areca palm, wrapped in the leaf of the betel vine, dusted with slaked lime, which is calcium hydroxide. Chewed together, they release an alkaloid called arecoline, a mild stimulant that brings warmth, alertness, and a gentle sense of well-being, along with a flood of red saliva that dyes the teeth and gums a deep, unmistakable red-black. That staining is the key. Where the traces of most ancient drugs rot away to nothing, Betel leaves its signature painted directly onto the enamel of the teeth, and that survives in the ground for thousands of years. At Duyung Cave on the island of Palawan in the Philippines, archaeologists found a burial with teeth stained by exactly this habit, dated to somewhere around 4,000 to 5,000 years ago. And At Spirit, a cave in northern Thailand excavated by Chester Gorman, remains of the areca nut and the Betel vine turn up in layers reaching back 7 to 9,000 years. Follow those stained teeth across the map, and they trace one of the great human migrations. Beetle-marked burials appear across Southeast Asia, at Neolithic sites such as Man Bac in northern Vietnam, out onto Guam in the Mariana Islands, and across the wider Pacific, following the path of the Austronesian seafarers as they colonized island after island. They carried the areca palm with them the way later travelers carried coffee or tea, planting their stimulant into every new shore they reached. The drug did not just travel with the migration. In a real sense, it rode along inside it, bound up with ritual, with hospitality between strangers, and with courtship, the same roles Betel still plays across South Asia and Oceania today. Two details make Betel more than just early. First, its sheer persistence. It is, to this day, the fourth most widely used psychoactive substance on Earth, after caffeine, alcohol, and nicotine, chewed by an estimated 600 million people. A habit visible in Stone Age teeth is still a daily ritual for a tenth of the living world. Second, and more revealing, the recipe itself. The slaked lime in the quid is not there for flavor. It raises the chemical environment in the mouth, freeing up more of the aregoline so the body can absorb it. In other words, these people were potentiating their drug, boosting its effect by combining ingredients with no knowledge of chemistry whatsoever. This was not simply eating a plant. It was following a recipe. There is a darker modern echo, too. Chronic betel chewing is strongly linked to cancers of the mouth. A habit that stretches back to the Stone Age is still, right now, killing the people who practice it. And betel is not even the only drug whose earliest date has recently leapt thousands of years deeper into the past. For a long time, the story of tobacco began only a few thousand years ago, with carved pipes and residue in the American record placing its use at roughly 3,000 years back. Then, a single hearth in the desert rewrote the timeline. The place is called the Wishbone Site, out on the flats of the Great Salt Lake Desert in Utah, on the edge of a long-vanished wetland. In the year 2021, the archaeologist Darren Duke and his team reported what they found in that ancient fireplace. Among the ash and bone sat 4 tiny charred seeds of wild tobacco. The hearth was radiocarbon dated to about 12,300 years ago, deep in the final stretch of the Ice Age. At a stroke, that pushed the documented human use of tobacco back roughly 9,000 years earlier than anyone had proof of before. Several things about this find matter. The people who lit that fire were not farmers. They were mobile hunter-gatherers moving across a cold, wet landscape, and they were already using a potent stimulant plant with no agriculture behind it at all. That overturns a comfortable assumption that intensive drug use had to wait for settled farming life. The seeds were found together with the bones of ducks and with stone tools, sitting inside an intact hearth, which argues strongly against the traces being some modern contamination. And wild tobacco is no gentle thing. Its nicotine reaches the brain within seconds of being smoked or chewed, triggering a rush of the reward chemical dopamine. In high enough doses, tobacco is not merely a stimulant, but a full hallucinogen, and a dangerous, near-lethal one, which is exactly how it was later used by shamans across the Americas seeking visions. Remember also that the rest of the world did not even meet this plant until the voyages of Columbus in the year 1492. Yet, on the American continents, the habit was already 12,000 years deep. The wishbone hearth teaches the single most important lesson in this whole investigation. 12,300 years is not the moment tobacco use began. It is simply the oldest moment we have so far been able to prove. It is a floor, not a starting line. Push the methods further, and that floor will almost certainly drop again. And this is the point where our species stops merely finding drugs in the wild and starts doing something no other animal does. It starts building them. The place to watch that leap happen is a Neolithic village called Jiathu in Henan Province in central China, occupied between roughly 7,000 and 5,700 years before the Common Era. Jiathu is already famous for other reasons. It gave us some of the oldest playable musical instruments in the world, flutes carved from the wing bones of cranes. Along with marks on shell and bone that some scholars read as a distant ancestor of writing, it was a sophisticated place. But for our story, its importance is chemical. The archaeologist Patrick McGovern, sometimes called the beer archaeologist, specializes in coaxing the ghosts of ancient drinks out of the pottery that once held them. Studying residues scraped from Jiahu's clay vessels and publishing in the year 2004, McGovern and his colleagues identified a fermented beverage made from rice, honey, and fruit, most likely hawthorn or grape. It dates to around 7,000 years before the Common Era, which makes it the oldest chemically confirmed alcoholic drink anywhere on the planet. The detective work is worth pausing on, because this is not guesswork. The team identified specific chemical fingerprints, tartaric acid pointing to grape or hawthorn, compounds from beeswax pointing to honey, residues pointing to rice. Together they reconstruct an actual recipe. The reconstruction was so complete that a modern American brewery, Dogfish Head, worked with McGovern to recreate the drink and sell it as a real beverage, a 9,000-year-old recipe poured into a modern glass. And a recipe is the whole point. Finding fermented fruit on the ground, as the drunken monkey did, takes no thought at all. Making this drink takes intention. It means gathering the right ingredients, deliberately encouraging fermentation, and storing the result in vessels built for the purpose. This is the difference between stumbling on a drug and engineering one. That leap may have shaped civilization itself. There is a long-running debate going back to the archaeologist Robert Braidwood in the 1950s, sometimes called beer before bread. It asks whether the desire to brew alcohol, rather than simply the need to eat, helped drive humans to first domesticate cereals like wheat and barley. Other researchers, such as Brian Hayden, connect early alcohol to great communal feasts, the kind of status-building gatherings that could knit scattered people into complex societies. At the great ritual site of Göbekli Tepe in Turkey, huge stone vats hint, controversially, at brewing on a feast day scale. Alcohol, in other words, was never only a drug. It was a technology. Fermentation made unsafe water drinkable, killing off many of the microbes that lurked in a still pond, and it preserved precious calories from harvest through the hungry months of winter. A jar of fermented grain was food, medicine, safe drink, and intoxicant all at once, which may be why the practice appears independently on every inhabited continent. McGovern argues that the making of fermented drinks is very nearly a human universal, invented over and over by peoples who never met, precisely because it solved so many problems in a single vessel. Every later confirmed milestone, the earliest wine from the country of Georgia around 6,000 years before the Common Era, the earliest barley beer from Göbekli Tepe in Iran around 3,500 years before the Common Era, comes after Jiahu. At Jiahu, we catch our ancestors in the act of doing the one thing that truly sets human drug use apart, not discovering a substance but manufacturing one and writing down, in the language of ingredients, the first recipe. Yet the moment we chase the drug that leaves almost nothing behind, all this hard evidence begins to dissolve. Mushrooms are the hardest case of all for a brutally simple reason. They rot. A mushroom is mostly water and soft flesh, and it leaves behind no seed, no shell, no lasting residue in the ground. So the evidence for ancient mushroom use is almost entirely indirect, resting on rock art and on the memory of living cultures, and that makes it a battlefield of interpretation. The most cited example lies in the Sahara at Tassili N'Ajjer, in southeastern Algeria, a landscape of rock paintings first widely documented by the explorer Henri Lot in the 1950s. Among its figures is one, thousands of years old, that shows a running form clutching mushroom-like shapes, with what appear to be more mushrooms sprouting from its very body. The Italian researcher Giorgio Samarini argued in the year 1992 that this depicts an ancient mushroom cult and a specific psychoactive species. Critics counter that the shapes are ambiguous, that they could be arrows or flowers or something else entirely, and that we are seeing what we hope to see. A similar argument surrounds the Selva Pascuala mural in Spain, painted around 6,000 years ago, where a row of small dome-capped figures has been read by some researchers as a local hallucinogenic mushroom, Psilocybe hispanica, which still grows in that region today. Suggestive, but again unprovable from paint alone. This is where three competing views sit side by side, and each deserves a fair hearing. The mainstream position is that ancient mushroom use was almost certainly real, but is nearly invisible to archaeology because the evidence simply does not survive. The art historical position is that specific murals may genuinely record it, though we can never fully prove any single one. And then there is the fringe, most famously the stoned ape hypothesis of Terence McKenna, who argued that psilocybin mushrooms actively drove the rapid expansion of the human brain, sharpening vision and firing up language. It is a spellbinding idea with no fossil or a genetic support whatsoever, and mainstream science treats it as unfalsifiable, but it is worth naming honestly rather than simply mocking. What is not in doubt is that mushroom use runs deep in living memory. The Aztecs called their sacred mushrooms teonacatl, the flesh of the gods, a use recorded in horror by the Spanish friar Bernardino de Sahagún in the 16th century. In the highlands of Guatemala, archaeologists have found strange carved mushroom stones, some more than 2,000 years old, that many researchers connect to exactly this kind of ritual. And in the mountains of Mexico, the Mazatec healer Maria Sabina guided mushroom ceremonies within living memory. The antiquity of the whole practice was underlined by a discovery at Cueva del Chileño in Bolivia, where a shaman's leather pouch around 1,000 years old tested positive for a whole cocktail of psychoactive compounds at once, proof that carefully assembled drug kits are themselves ancient. And psilocybin, the active compound, works exactly as our first chapter predicted by mimicking one of our own neurotransmitters slotting into a serotonin receptor in the brain. Here, though, the solid archaeological trail goes quiet. The painted wall may be the oldest testimony we will ever have, or it may just be our own reflection staring back. And if the evidence can be this fragile, we have to ask honestly how much of the entire timeline we can actually trust. This is the uncomfortable heart of the whole subject. Almost everything about the deep history of drugs is shaped less by what happened and more by what happened to survive. Organic drugs decay. Leaves, petals, fungi, and brewed liquids vanish within years. We catch sight of ancient drug use only in the rare moments when it left something durable behind, when it stained a tooth, charred in a fire, or dried onto the inside of a pot. That means the record is not a fair sample of the past. It is wildly skewed toward a few lucky substances. Betel survives because it dyes enamel. Tobacco at Wishbone survived because its seeds were charred hard in a hearth. The countless plants that were chewed, brewed, or burned without leaving such a mark have simply disappeared from history. So every single date in this story is a floor, the oldest thing we can prove, and never a ceiling, the true beginning. Even the evidence we do have resists easy reading. Molecular archaeology, the kind McGovern practices, can confirm that a compound was present, but it usually cannot tell us whether the substance was swallowed on purpose, or in what amount, or why. And beneath that sits a deeper trap, a problem of categories. We carry a tidy set of boxes in our heads labeled medicine, food, ritual, recreation, and poison. There's no reason to assume the people we are studying carried the same boxes. The yarrow in that Neanderthal's mouth could have been medicine, or diet, or a way to flavor meat, or something we have no word for. The very phrase doing drugs presses a modern frame onto an ancient act that may not have seen itself that way at all. The Persian Jurd at Shanidar is the perfect warning. A beautiful human story, Neanderthals burying their dead in flowers may turn out to be the work of a hoarding rodent. Radiocarbon dating, our most trusted tool, tells us when a piece of organic material lived or burned, not necessarily when it was used as a drug. And so the phrase absence of evidence is not evidence of absence carries unusual weight here, because the evidence itself is so perishable that its absence is all but guaranteed. Remember, too, how fast the picture keeps changing. A single desert hearth moved the tobacco timeline 9,000 years in one paper. The only intellectually honest conclusion is that there is no clean starting point to be found. There's only a set of provisional floors, each one waiting to be pushed deeper, and a true beginning that is lost forever in everything that rotted away. So step all the way back and look at the shape of the whole thing. The answer to when prehistoric humans started doing drugs is not a date. It is a stack of 3 layers, each far older than the one our instinct reaches for. At the bottom lies the molecular layer, the receptors in the brain, and the alcohol-taming enzyme in the gut, tuned across tens of millions of years, long before our kind existed. Above that sits the behavioral layer, the drive to seek out plants for medicine and for altered states, shared with chimpanzees, with sheep on their ledges, with reindeer and jaguars. And only at the very top sits the thin, recent human layer, the recipes and rituals, the brewed jars of Jiahu. Laid out in time, the dates do not mark a beginning. They mark a deepening. The 10-million-year-old enzyme. The Neanderthal planta used around 50,000 years ago. The betel and tobacco reaching back 4 to 12,000 years. The first deliberate brew some 9,000 years ago. It is a slope running down into the dark, not a single doorway we once stepped through, which quietly transforms the question itself. Asking when humans started doing drugs turns out to be almost the wrong question. The truer version is this. When did any creature with a brain and access to these plants ever stop? What actually makes us unusual is not that we use these substances. Nearly everything with a nervous system, given the chance, seems to. What makes us unusual is everything we built on top of the using. We are the only animal that manufactures its drugs, that wraps them in ceremony, that trades them across oceans, that outlaws them, and that studies them under a microscope trying to understand its own longing. There's a hard modern lesson folded into that deep time view. Our appetites were shaped by 10 million years of weak, rare, hard-won doses, a few percent of alcohol in a fallen fruit, a bitter leaf chewed against a toothache. We now live drowning in strong, cheap, endless ones, in purified powders and distilled spirits and engineered products the drunken monkey could never have imagined. The trick of distillation is only a couple of thousand years old. The refining of plant extracts into concentrated drugs is younger still. Our biology never had time to adjust. The ancient inheritance and the modern supply do not match, and that mismatch, an old brain meeting a new abundance, is much of what we call addiction. Seen this way, drug use is neither a modern vice nor a simple failure of willpower. It is something written into the nervous system long before there was anyone to take the blame. Picture it as a single vine of shared chemistry threading unbroken from a piece of fermenting fruit on a forest floor, through the aching jaw of a Neanderthal in a cold Spanish cave, all the way to the present day. The oldest thing about being human, it turns out, might be one of the things we still least understand about ourselves. If the deep past still has questions waiting for you, there's another investigation ready on your screen right now, and subscribing keeps them coming.